नहीं जो रोस्टम कोई नहीं। यार ये जो है ना, ये तो मिनिस्ट्रीज के
ओके, यू आर लिसनिंग मी?
सर आवाज आप अपनी खोलें, म्यूट कर, अनम्यूट करें सर। डॉक्टर साहब अनम्यूट करें सर, आप अपनी तरफ से अपने लैपटॉप से डॉक्टर साहब अपना अनम्यूट करें।
आपकी आवाज नहीं आ रही।
तो आवाज आ रही है?
ठीक है।
और सेंटर करें सर, सेंटर करें तस्वीर।
शेख साहब जहाँ पे मैं बैठा हूँ वहाँ 0 डिग्री टेम्परेचर हो रहा है।
अच्छा
अच्छा,
सर सेंटर करें अपनी तस्वीर को और नाले मफरल ला दो सर, तुसी की है
माशाल्लाह। और हमारे साथ डॉक्टर बहीउद्दीन खान साहब है यहाँ से। बहीउद्दीन खान साहब आपकी तस्वीर नहीं मुझे आ रही। ये अमेरिकन सोसाइटी ऑफ सिविल आवाज नहीं जाएगी। अमेरिकन सोसाइटी ऑफ सिविल इंजीनियर्स के यहाँ स्ट्रक्चरल कमेटी के चेयरमैन है
जी। कहाँ पे? यूके में? उधर यूएसए में जी। और डॉक्टर साहब ठीक है ना आप? अस्सलाम वालेकुम।
जी साहब, वालेकुम सलाम। और सदीक साहब आप यूके वापस पहुंच गए हैं माशाल्लाह।
बिल्कुल। और मौसम भी काफी सर्द है।
मौसम सर्द हो गया ना,
हवाएं तेज चल रही
तो तेज चल रही है।
यस साहब, आप कौन से मौसम, बाहर के अंदर के मौसम की बात कर रहे हैं?
जी ये बाहर का मौसम है, 0 डिग्री टेम्परेचर है।
हाँ जी, अंदर का आप जो चाहें कर लें।
अंदर तो जो मर्जी कर ले, वो थर्मोस्टेट लगा हुआ है।
मियां साहब से डॉक्टर पूछ रहा हूँ।
जी मियां साहब,
अंदर और बाहर से वैसे बड़े हॉट हैं।
दो बातें कर रहे हैं, टेम्परेचर पूछ रहे हैं कमरे का अंदर से और फजा का बाहर में। तो डॉक्टर साहब तो वो और भी पूछ रहे हैं कुछ, मियां साहब
और भी पूछ ले, अगर कुछ पूछ रहा है तो आप और भी पूछ ले
कि अंदर का टेम्परेचर का क्या हाल है।
प्रोग्राम शुरू करो।
जी
डॉक्टर साहब विद योर काइंड परमिशन लेट अस स्टार्ट द प्रोसीडिंग।
जी अभी थोड़े से लोगों को एंटर करने दे। ये कामरान मसूद साहब भी हमारे पास मौजूद है। कामरान साहब क्या हाल है आपका?
अल्हम्दुलिल्लाह।
कामरान साहब हमारे साथ मौजूद है। ये इलेक्ट्रिकल इंजीनियर है। बहुत सा वक्त इन्होंने सऊदी अरब में गुजार दिया है और अब पाकिस्तान में है, वापस जाने का नाम नहीं लेते। क्यों कामरान साहब, काफी हो गई है सऊदी अरब में?
नहीं, अब सारी उम्र तो नहीं रह सकते ना वहाँ।
सारा वक्त तो नहीं रह सकते, यही बात है ना।
इतनी उम्र हो गई अब,
सही कह रहे हैं।
रिटायर्ड लाइफ गुजारने का भी तजुर्बा हो रहा है। अच्छा है।
तो अच्छा जी, हमाद साहब, आपको मेरी आवाज आ रही है? जी हमाद साहब, कुछ जितने लोग एंटर हो जाए तो फिर हम शुरू करते हैं। और आप तलावत करेंगे और इजाज शेख साहब इंट्रोड्यूस कर देंगे और फिर मुझे आप होस्ट बना लेंगे। तो शेख साहब आप बुला लें इनको, अब्बास साहब को तिलावत करा लें और आप इंट्रोड्यूस कर दें और देख लें कितने लोग एंटर हुए हैं। इस वक्त 22 पार्टिसिपेंट्स है मेरे पास जो फिगर है वो 22 पार्टिसिपेंट्स है। मेरा ख्याल है हम शुरू कर सकते हैं।
अच्छा सर, ये जो अपना ख्वाजा अब्दुल वहीद साहब हैं।
हेलो जी एक सेकंड। हाँ जी वालेकुम सलाम। जी बताएं।
फिर मैं बाकी
मैंने आपको मीटिंग आईडी भेज दी है और पासपोर्ट कोड भी भेजा है, आप एंटर हो जाए। जी भाई साहब।
सऊदी अरेबिया में कहाँ रहे?
सर गल्ला ना करो,
चलो कोई बात नहीं,
बात कर लो ना।
जी बताएं, सऊदी अरब में कहाँ पे रहे आप?
प्रोग्राम शुरू कर दो सर।
मैं इससे पूछ रहा हूँ, मैं उसके बाद शुरू करते हैं प्रोग्राम।
कामरान साहब, सऊदी अरब में कहाँ रहे आप?
मैं सऊदी अरब में खुबर में रहा हूँ, जद्दा में रहा और ज्यादा अरसा रियाद में रहा हूँ।
राइट।
मैं भी सऊदी अरब में रहा हूँ, लेकिन मैं टाइम में था।
माशाल्लाह माशाल्लाह।
सिकीको के साथ।
मैं भी जो आखिरी 10 साल में वो सेक के साथ है, वही सकी को
पहले सेक था, लेकिन फिर उसके बाद सकी को जब बन गई ना उसमें मैं था।
आजकल सेक है
जी,
और इसका नाम एक और बन गया, वो नेशनल ग्रिड।
ठीक है। Now let us start the proceeding now.
जी स्टार्ट करें।
I request
आप शेख साहब स्टार्ट करें, हमाद साहब से तलावत करवाएं।
कर रहे हैं सर।
now we are starting the proceeding with the recitation of from the Holy Quran. Mr. Hamad will recite a few verses from the Holy Quran right now. Please, Mr. Hamad. Hafiz Hamad, that.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر. صدق الله العظيم.
Jazakallah.
Now the starting is from the introduction of Dr. Javed Yunus Super. Everybody knows he is very much associated with the institution of engineers Pakistan, giving his volunteer services to the IEP. At the moment, he is the president of the IEP of Pakistan, Institution of Engineers Pakistan overall. And he is making the major contributions in conducting the workshops, seminars, conferences, and everything. He is fully devoted for this job over here. In addition, he is a very good, competent consultant also of his own field, that is the civil engineering. But in addition to that, he is making a major contributions in the different events of the IEP. And this is, he has, he has just making this seminar, this workshop, the training, this subject that is of the smart technologies. That is the latest technologies. The Dr. Saab will deliver his speech on the subject, and we are here to listen properly. Dr. Javed Yunus Super Saab.
बहुत शुक्रिया वहीद साहब, बहुत शुक्रिया आपका. You have introduced me very nicely. Thank you very much. Can everybody see the screen? I have come on the screen. Can you see the screen?
Yeah.
So I think that's quite nice. Bismillah ar-Rahman ar-Rahim. And today we will be talking about smart city technologies. And this is a training workshop, and we have just started, and we have about 3 hours to go, and you will give me patience hearing, I hope. And this small city technologies, we need to know a lot about it. Now, registered participants today are about 80 of them, and as they are entering into the room on Zoom, we will be appreciating them and letting them contribute and participate, and we have a lively discussion together. We can talk in Urdu, we can talk in English. And noted participants today are ex-chairman WABDA, Sayyid Raghab Abbas Sahib, who is chairman of Hyderabad Center of Institution of Engineers Pakistan. Among us also, we have engineer Salim Raza, who is the Secretary Government of Balochistan in Quetta, and we have other very important people around, and I think we'll have a good company. And remarkable among us is Dr. Habib Khan from American Society of Civil Engineers, Structural Engineers chapter. He is the chairman of the Structural Engineers Committee at New Jersey. So among us are also Raid Sheikh Saab, who has in fact introduced me, and Nia Sadiq Saab from the UK, and he is a senior advisor to the local council, urban development, and he has been participating with us very frequently, and we are grateful to him that he is together with us. And we have also Mr. Taimur Azam of National Technology Council, CyberNet Private Limited. So we are entering into a field of smart cities technology. Smart cities technology, that the idea came to me that we should offer a workshop on it, because very recently Islamabad has taken up these small city technologies, and now it is coming to Lahore. So let us go slide by slide and see what we have to do in this respect. And we really have focused on small cities technologies, because this is the future of Pakistan. This is the future of our engineers and information technology specialists. And I would like them to learn as much as possible. These smart city technologies are the future, and it is coming to Lahore now. The first small city planned by Surba Jurong of Singapore. Now, I'm not really very happy about jobs going abroad. I think this was the right time that Pakistani engineers and Pakistani IT specialists should have been trained enough. And some of them are, in fact. It's only that they are hiding here and there, and they are not in the front line. And the job has gone to a Singapore company. Now, anyway, say good luck to us, and good luck to Surba Jurong of Singapore. And this small city, Lahore small city, has already gone into under construction. And LDA has given its approval in April 2021. And there are more smart cities coming. The Punjab government has already approved a plan of engagement of consultants. They will go into Sialkot and then Sahiwal or maybe Faisalabad. So Planning Commission has already started entering these cities and turning them into smart cities. Now, there are opportunities. There are a lot of opportunities for employment. And if the engineers and our IT specialists grumble that they don't have many opportunities, this is wrong, because opportunities are there. It's only that you need to really get ready, need to prepare yourself, and you to have the skills that are involved in these smart cities technologies. These smart cities technologies, when we go through this course, you will find that a lot of technologies are already there, and we are quite familiar with them, some of them, but it's not really coming up from the city administration. It is rather scattered individually. We are entering into smart. We have smartphones, we have smart iPads, and we have internet, and all these individually we are already into it. These smart technologies are there, but it's not there on the public administration level, on city planning and administration level. So we need to see that how governments can come into it. The government has already, this Alpha Tower in Lahore, we all know they have made a lot of effort and to turn the government functions into smart functions. And we need to train ourselves. And here, I think in this course, there are about 80 participants. Now, 80% of them are fresh graduates, and some of them are even in their final years. Then among them are graduates of 0 to 5 years studying. So they are about 80%. And this is the population, in fact, we need to address. And we need to tell them that smart cities technologies is the future, and they should adopt these technologies, be familiar to them as much as possible. Then about 15% I have seen the registered participants. 15% of them are senior level people, principal engineers, and directors, deputy directors. They have spent some time in various matters of civil engineering, but they are most of them are not really directly engaged in turning cities into smart practices. So here there is a point of training, point of getting familiar, point of awareness. Now, about some of the people who are here with us are already experts in information technology and operational technology. So the information technologies and operational technologies combined together, they get into Internet of Things. This is called Internet of Things, IoT. This is networking. We will go step by step and we see what networking is, and they get into platforms, and we will get into see that what are those platforms and how we can make use of, how we get registered ourselves into platforms, and how all this works really. So let me come to the next slide. Let's talk a little bit about this the HorseBot city, which is being advertised and being advertised a lot really, and people are booking their plots into this smart city, and it is really located at Lahore bypass. Lahore bypass, when Lahore bypass crosses GT Road, and then there is M11 which goes to Sialkot. So this is these are two. On one side is GT Road, the other side is. I'll come and show you the map where this location you can find that they have really planned to develop about 55,000 canals of land. And as they report, out of 55,000 canals, and they have already acquired about 20,000 canals of land. And LDA has granted approval in April 2021. Now, what they are targeting their advanced amenities and modern designs and excellent infrastructure, and ultimately a connected platform where they can administer the city and they need to run this place as a smart city. This is the second experiment, really. The first experiment is being done in Islamabad. Islamabad is the first smart city being developed out of, I think there are about 174 smart cities so far in the world. In the world today, there are 174 smart cities already in operation. And Islamabad is going to be the 175th, and maybe Lahore next month. So let's hope for the best, and let's hope that we participate into it, and let's see how we go about building Lahore smart city to a real smart city as they claim. As you see, let me go to the next slide. We'll show you the back. On the left, you see Lahore bypass. And this Lahore bypass crosses GT Road. And this is the corner point, the southernmost corner point of Lahore smart city. Then Lahore bypass continues, and it joins M11. M11 really starts from the Roghawala, Lahore, and it goes to Sialkot. So this Sialkot motorway is on the right side of Lahore smart city, and GT Road is on the left. And on the right, you see the master plan. As you see the master plan, there are quite a number of blocks around. So there is an overseas executive block. There is the overseas block, and there's another executive block. At the bottom, you see a commercial block. Then on the right, there is this general block and an education block, and there is a golf course, and it's about 20,000 canals of land. Quite a area, and as you see, booking is taking place, and people are booking their. Some of them are going into commercial plots, and others are getting into overseas blocks and educational blocks. These are also on the way. So this is the right time. I think we should know that this is happening right here in Lahore, and we should be familiar with the technologies involved with the smart city. And I think this slide you see on the right, you see the under construction. This is the main boulevard, which is under construction, and on the left top, you see the access. I think this is GT Road, and just before the interchange, you can turn right to pass on to M11, and from M11 you can take up course to airport, and there is a joining of M2 as well through Lahore bypass. So this is a very interesting and very important location. Here we hope to have a good quality of life for the residents and the people who are doing business there. And we hope to develop this place as a smart city. And we come to the next slide to see what are their really claims as far as smart city is concerned. So this Lahore smart city, if you look at it, these are the claims. So there's going to be a smart traffic management system, a smart education system, a smart air pollution system, and there will be an open data sharing. So open data sharing really means public-private people working together. It's a kind of a vertical integration. A vertical integration. We are not used to it really. We are not used to kind of a situation in which people participate in the data sharing and in seeing what decisions are taken place and contributing and participating into such decisions. Then because of a lot of these communication signals, we need to have electromagnetic emissions control. So without electromagnetic emissions control over the city, signals will drop and signals will have problems. And so then individual buildings are going to smart buildings, smart homes, smart street lights, and smart water management system. Then smart electrical vehicle charging depots, smart parking areas. And we'll see, what really it means. This is an array of the facilities we are going to have in a smart city. But let's see step by step we get into a useful working situation in which these intelligent devices can help us into operations of a really smart city. Then there is going to be a water quality control, smart water quality control, a smart energy management system, a smart gas water leakage detection, smart public safety, and smart health, a smart health unit. So we will talk about all this, what really means when we talk of a smart health unit. And all this is managed by a system which is called Internet of Things. And we will also talk about what does it really mean, Internet of Things, IoT. IoT is the crux of the matter, in fact. Now, what is a smart city? Let's get into the bottom of it. And what do we really mean by a smart city? As you see from the slide, it is a vertically integrated and controlled public bodies and residents together. A friendly place to live in and to do business. Now, the important aspects of this is a vertical integration. Vertical integration means people and parties, companies, business units interacting not only together but also with the city administration. So it's a pool of information, gathering information, collecting information, handling and analysis and decision making. So how it is done? How is this integration done? How people participate? How information rolls around everywhere? This is done by use of networks. And networks, how networks work, how networks are connected together, and how they connect to the applications. I think a lot of us who have smartphones, they know what applications mean. And then leverage devices. All these leverage devices are connected together, and this is all called intelligent connectivity. I think most of us who have smartphones, they already experience this connectivity. We don't really know what goes beyond, what goes underneath. When we use a smartphone, where do we get connected? Who is connecting us? Who is watching us? And what information we have on our smartphones. So it is already there, but it is there on maybe scattered level, on individual level, and now it is going to be there on a public city administration level. And these smart city technologies are basically ICT, information communication technology. Basically, ICT has expanded itself, and it has made all these networks and interconnected situations. Now, then digital tools, because all this is based on digital technology and integrated system, and we call it a digital framework. Places get connected together, and houses get together, and data centers get together, and they work together in an intelligent, connected situations. Now, objects and machines transmit data. Really, all this is based on transmission of data, and transmission of data, and then it is collected, it is analyzed, and then information, the decision-making phase takes up from there. And this is really a cloud-based IoT application situation. So what is a cloud, and what is a network, what is a platform, and how all this is connected together, and how all this enables a city administration to check its traffic, to check its health, to check the education, and to check the water quality. This is all already prepared there, and it is already really matter of getting into it and start functioning. Now this system, the system of systems really, the system of systems get together, integrated together vertically, and it all involves governance, society, environment, and economy. And this is basically information communication technologies infrastructure. And it gives rise to mobility and real estate buildings, industrial and manufacturing, utilities, electricity and gas, water quality and water management, and safety and security, healthcare, education. So all this is handled by systems of networks and information, gathering information, information handling, and decision making from such information situations. Information communication technologies infrastructure. Bottom layer, as you see from the slide, bottom layer is a data acquisition layer. A data acquisition layer really means sensors. So, in order to obtain data, you need sensors. And sensors are placed in devices. Maybe your your mobile smartphone has sensors in it. It transmits information you may not be aware of. Then there is another source of information transference or information acquisition is radio frequency identifiers. The radio frequency identifiers mostly are fixed on equipment, on maybe mobile vehicles and places, and they transmit what they see, what they sense, and information identifiers are spread all over around, and because of these sensors and radio frequency identifiers, a lot of information goes up into a network communication layer, and it is analyzed, and it is transferred into decision making. And then there are actuators. Actuators really are devices which start performing functions, such as a siren. Maybe siren starts generating loud noise to warn any kind of emergency, and these actuators are maybe a bulldozer starts working, and an actuator is also maybe driverless vehicles, as you have heard. There are driverless vehicles these days, and the vehicles, they just travel on the road without any driver. Then cameras are fixed all around in the buildings, on the streets, everywhere, and they take pictures, and the pictures are fed into networks, and then there are data centers. There are data centers which analyze such information. Now you'll be surprised. Most of you must be knowing already. You'll be surprised that how many people work in these information communication technologies systems all over the world. All over the world today, as I have gathered this figure, is 55.3 billion. 55.3 million people are full-time employees at various data centers all around the world. 55.3 billion people. As you know, Lahore's population is about 12.5 billion. So you can easily see that about 5 times population of Lahore. That's quite a real big figure. But you look at the population. This is not all ages, but these are workers which are trained in information communication technologies. They are full-time employed today worldwide, and mostly the work is done at data centers, various data centers all over the world. They are spread all over the world. The largest data center is in USA, Tahoe Reno. It is built over a land of 1,000 acres and 7.2 million square foot of construction. Such a huge complex, and all that is data centers. There are data centers. Now, each platform has its own data center. Like Google. Google has about 15 data centers located. 8 of them are located in the USA. 1 is in South America, and 4 are in Europe, and 2 are in Asia. And if you look at Amazon has 54 data centers all around the world. And now these data centers get information from servers. servers are spread all around the world too, but there are quite a number of servers around. For instance, Google has 900,000 servers. You can well imagine how many people, how many places are busy in handling information, transforming it into useful analysis, and making decisions. Amazon has 1.4 million servers, and Facebook has 30,000 servers. So you can well imagine how busy people are in obtaining information, analyzing them, and making decisions. And let's go to the next slide. Yeah, while we are talking about and we are explaining this slide, there are 7 comments on the chat. Hamad Sahab, can you respond to these comments? What comments people have made? There are 7 comments I can see on the chat. On the chat room, if you go into the chat room, there are 7 comments. So please look after these comments. Hamad Sahab, this is for you. Now, this ICT infrastructure in SSC, they call it. This is a physical city physical infrastructure like piped water, sewage, electricity, gas, waste management, knowledge infrastructure, health infrastructure, transport infrastructure, road infrastructure, and buildings, etc. This physical infrastructure with the sensors with them, they transmit information to a sensing layer. There is a sensing layer and the networks there. SCADA is a very well-known network. I think a number of engineers are already familiar with SCADA. These servers to transmit this information, these are also called nodes, terminal nodes. Terminal nodes are really sensors, transducers, actuators, cameras, radio frequency identifiers, and barcodes, scanners, and GPS trackers, etc. So this is all spread all around. We got that too. They signal information, and information goes through networks, and then there are systems, software systems which analyze this information. Systems are like this SCADA and this WPAN and HART and video surveillance systems. Then there is at the top there is a network layer, as you see. And this layer also has hardware and software systems in these data centers which we have talked about, and they do networking. In fact, they make this information available to where it is required and where it is to be analyzed. Then there is a support layer, databases, data process services. We'll talk about all this in detail, and some of us who are not really familiar with all this systems. I will go into basics as well. And some of us who are already partly familiar, you get familiar if you have a smart iPhone anyway. So at the top is the application layer. Who are the applicants? E-government, transport, logistics, district management, healthcare. These are all applicants. The people, the administration who uses all this information when it is available to them through these systems of systems. So this is how it works daily. Ahmad Sahab, you need to look at the comments people are making on chat room. There are 13 comments. Please see what people are saying and handle them, one by one. Look after them one by one. This will be quite okay. This is the whole system really on one slide. It has been hard to make a slide as this one, which really explains how things are done, how things happen. And at the bottom of it, as you see, is IoT transaction. IoT really is Internet of Things. We'll come to it. What does it really mean? What does it mean, Internet of Things? On both sides of it, you see APIs. These are application inputs, and it goes on the strip. As you see, a strip is a AL technology big data strip. Now, facial recognition, voice recognition, blockchain system, emotional recognition, AID, iRobot, unmanned vehicles, and e-learning, and many others. Then on the top, as you say, we are here on smart city. Smart city administration. They handle all these. They make standards, in fact, and they make use of the software to run a smart city as long as transportation is concerned, medical care is concerned, security is concerned, and the residences are concerned, and e-government is concerned, education is concerned. So, with the help of IoT and the help of these softwares which are available to smart city, they can do service to all these aspects of the city. In a nutshell, this is a conclusion, really. It's a nutshell what we have been talking of. A simple smart city solution contains one or more connected devices and sensors, and these provide their data, possibly via a gateway, if local aggregation is necessary to a platform. So we have devices in which there are sensors, and these sensors collect data, and this data is passed over through a gateway, and ultimately it reaches platforms. The role of the platform is twofold. One is to activate, monitor the status of devices, and remotely manage their configuration. This is one role. to monitor the devices and their status and manage their configuration. And the second role is to help developers to build, deploy, and manage individual applications. So this is the second role of a platform. So you can register yourself in the platform, obtain their working and get into it as a registered user, and you need to pay for it really anyway, so that these packages which are made available to you, you can handle street lighting, smart parking, traffic flow management, etc. Now, these applications, they are based on information technology, but they are connected to operational technology. Now, operational technology, we are all very much familiar. Operational technology really is a servo mechanism, as you see, sensor and actuator. In order to utilize this operational technology, you really have systems, control systems. This is control systems domain, and mechatronic engineering domain, really. A patchwork of local and wide area communications technologies provides a connectivity fabric between these components, which are distributed in remote locations within the premises of a city's technology infrastructure or in a service provider's cloud. So this is a summary, really. Now, some of us know already these terminologies. They know what a cloud means. They know what a platform is. They know what is an operational technology. They know what information technology. But many of us, they are not aware. They don't know really. So this is the time that we learn, and this is the time we get familiar with what these things are really, and how they function together, but how can we make use of them? So let us start from zero and start some definitions of these terminologies that we have used, so that we are all on the same page. Start from local area network and wide area network. Local area network is called LAN, and the wide area network is called WAN. Basically, when devices are connected together physically, they make a local area network. And local area networks are really private ownership, and rather than public ownership. Local area network really means there is a cable. It's connected to a server, and the communication is through that cable. That makes a local area. A wide area does not use a cable, because the area is so big, and information is transmitted to through satellite or through Wi-Fi, and these are called wide area networks. These devices are really connected to servers, and the servers are connected to platforms. So as you go higher and higher, you get into a global information pool. These devices are connected through gateways. What are gateways? A gateway is a computer that sits between different networks and or applications. The gateway converts information, data, or other communications from one protocol or format to another. The protocol is a language. In order to transmit information, you need to convert one format from one format to another format, from one protocol to another protocol. Basically, a router performs this function. A router is really a small gateway right maybe in your house or in your office. But a router has a connection through internet to a server. A router is kind of a networking layer system used to manage and forward data packets to computer networks. A gateway is simply a device or hardware that acts as a gate between the networks. It could also be defined as a node that acts as an entry for other network nodes. So nodes are connected to nodes, and those nodes are also connected to higher nodes, and ultimately these all networks combine together and they form systems, and then systems combine together, then they form systems of systems. The world today is all connected together. It's the right time we become aware of it. It's the right time that we make use of it. So, what is a technology platform? When we talk of technology platform, a platform in ordinary sense is a raised surface. Maybe you're familiar with the railway platform, all right? Physical railway platform. What do we call a platform? Where a train comes, stands against it, and you enter. Where you wait for the train comes, and you enter it. A platform is also kind of a graduation, or a platform is also a place from where you make a speech, and you really pour out data, pour out information that is communicated to your listeners. So this is in information technology sphere. Platform is also something like same, that you wait and then you enter your information, and this information is transmitted and it goes to networks, and then there are data centers who handle these networks, and they make decisions, analysis and decisions. Now, Windows or OS X Mac are examples of a computer platform. A technology platform refers to a specific platform on which technical architecture is laid out and is made to run. These platforms are really places where there is hardware, there is software, and this software is made out in such a way. This is called computer architecture. In such a way that it receives information and it performs operations through software, and then pours out the results. This is sometimes, this is most of the time it is done automatically at these data centers. But at these data centers, the supervisors are there as well. But physically, manually, the supervisors watch over what is going around, and where there are interruptions or failures, they look after these situations. So platform is mostly a mixture of hardware and software, and they provide these services to the users. Examples. What are the examples of these platforms? Amazon Web Services. This is a platform. Microsoft Azure is a platform. Twilio is an example of platforms. What do they offer really? What do they do? They offer computing, utility, interaction, networks, marketplaces, on-demand services, and crowdsourcing and data harvesting. These are typical words, terminologies of functions which are carried out at these platforms. Now, YouTube and Facebook are also open platforms. And these are platforms, they are used as a base upon which other applications, processes, technologies are developed. But they are not publishers. What is the difference between a platform and a publisher? Publisher is a source of data, and it's legally they are the owners of that data. But YouTube's, and when we said YouTube's and YouTube and Facebook are not publishers, that means they don't own the data. The data comes from somewhere else. The source is somewhere else. And they only process this data, and that's why they are called platforms, and they are not publishers. Now, Google is something super of all this. It's not just a platform. You can say it's a cloud platform because it offers cloud computing services. Then Instagram and TikTok are free online photo sharing and social network platforms. These are also platforms. But say TikTok is a photo sharing, and Instagram is a social network platform. We already know this. We use them. We get their benefits. But inside is that these are platforms. Platforms are places where there are computer hardwares and software, and there are people at data centers who handle all this. Now, Nadra, we know there is a Nadra record in Pakistan. Everyone, the data is registered there. Nadra, we know it. Nadra uses a platform that is called Nadra Kiosk. Nadra Kiosk is a platform, an e-commerce platform that has been given to exclusive use to Nadra. Now, if you want to enter into Nadra record, you need to be a registered user yourself. Now, again, there is a platform which is called Truth Finder. Interesting. This Truth Finder platform is used for criminal background checks online. Now, everyone doesn't have the access to such platforms, but there they are admitted people. If you want to get access, you need to get yourself registered. You need to pay some premium, and there are criteria. I mean, who can be admitted and who cannot be admitted. Similarly, TMS is a platform used for transportation management. TMS works fantastically because it receives information regarding transportation of the city. It receives information how many vehicles, what type of vehicles are coming into the city and going out of the city. Then it receives information at the traffic crossings as well. Now, conventional traffic lights, as you see, they are not internet connected. Conventional. They have sensors. The traffic lights and the crossings today, they have sensors. They pick up how much traffic is standing, and when to put a green light on, when to put a yellow light on, when to put a red line on. There is a timer in it, and there are the sensors as like a signal which lets the red or yellow or green light on. But this is not really connected to a platform. But smart crossing systems, they are connected to platforms, and platform looks at the city as a whole. So this is how there is a platform which is called TMS. And this TMS is a transportation management platform. So if smart city of Lahore, which is under construction today, they want to use this platform, they can use this platform. They need to register themselves there. They need to pay some premium, and they need to qualify themselves. Now, we use this word cloud a lot, and what it really means. What is a cloud? Some of us must be curious about it. Now, a cloud is actually a software oriented and services oriented outfit, and it runs on internet instead of locally on your computer. Some functions are there right in your computer. You don't have to go anywhere else. It's right into you. Maybe some softwares are already loaded, some apps are loaded into the computer. You don't go out of it. But when you go out of it, you engage a cloud to avail those services which are present in the cloud. Like transference of a huge data. If you have a huge data, you have clouds like Google Chrome, and you have a cloud like Firefox, and they are dedicated mobile apps. So most cloud services can be accessed through a web browser. These clouds are accessible remotely over the internet. So from your maybe laptop, from your iPad, or from your smartphone, you get into internet, and that takes you into a cloud where you can store data, you can run software services of what are needed. something which is stored in a cloud means it is not stored in your computer. It is stored at servers. That is the only difference. Examples are like Dropbox. I think many of us are already availing the services of a Dropbox. That is a file storage and sharing system. Similar cloud is Microsoft Azure, which offers backup and disaster recovery services, hosting, and many more. There is another cloud which is called Rackspace, and which offers huge data handling services. Graphically, a cloud represents something like a real cloud. A cloud has infrastructure, has a platform in it, and has applications. Now, you can approach a cloud through phones, through tablets, through desktops, laptops, and all this takes place in a server. All servers don't have that capacity, but some servers which have the capacity to act like a cloud, they offer these services. The cloud has infrastructure. The cloud behaves like a platform, and the cloud also has applications. As an infrastructure, it is a computer, it computes. It will do computation. Very large data handling computation it can handle. Then it's kind of a big blocks of storage and connects those storage blocks to networks. This is what the cloud does. Then it acts like a platform. As a platform, it identifies you, it identifies your users, and it has a runtime. It performs runtime services. Then it also has queuing services. So if it can't handle your object at one time, it will place you on a queue. And when your turn comes, it will offer your services. Then it provides a huge database. This is the function as a platform in a cloud. Then, as far as applications are concerned, what it is really doing, what a cloud is doing, over and above all this, we don't know, but somewhere some things are happening. These are happening to your data. Monitoring service, then content, the content handling, and collaboration. One cloud collaborates with another cloud, and it communications. Clouds communicate between themselves. Then it also runs financial control, because if things are happening and people are working, they are working 55.3 million workers are working in ICT, and their financing has to be controlled and monitored, administered, and this kind of services are also done on a cloud. Now we come to another aspect that is called Internet of Things, that is IoT. What does really IoT mean? Some of us are familiar with it, some of us are not that familiar with it. These things, the word things really mean devices. And these devices are objects, and every device has a sensor in it. The devices with sensors in it, they are called things. And when they are connected with internet, that is a special connected situation, connection of networks that are called Internet of Things. Now these devices are embedded with sensors, electronic software, which enable them to gather data and share it with other internet connected devices and systems without human interactions. So this connection of things with internet is called Internet of Things. Now, if you look at this slide, this diagram here, at the center there is a cloud. At the center is Internet of Things, and it has two-way connection to devices. Devices like iPhone, cameras, video recorders, audio recorders, solar sensors, microphones, heart monitors, stethoscopes, smart stethoscopes, stocks, tablets, engineering appliances, car trackers, date generator, timer, messenger, emails. These are all connected to IoT. What you send from your place to another place somehow is recorded on Internet of Things, whether it is noticed or not, or whether somebody takes any view of it, it's a separate thing. But there is a connection. The cameras, the smart cameras, not ordinary cameras, but the smart cameras. The smart cameras, whatever they take pictures, they send it elsewhere through, and they also have a connection to IoT. Similarly, video recorders, audio recorders, solar sensors, all devices which are smart devices, which have sensor in it, they can transmit data, whatever data, maybe mathematical data or pictorial data, whatever it is, or videos, they can all be sensed and manipulated and worked, and from their analytics go on to capture the whole situation. And this is how platforms get data from. How does an IoT system work? Now, this IoT system, I can tell you, there are quite a number of IoT developer companies in the world. quite a number of them. Can you imagine how many IoT developer companies are there in the world? 6.2 million. 6.2 million companies are working today on IoT. And 6.2 million companies, they work together through platforms. And today, if you see the figures, there are 620 IoT platforms working today in the world, such as Amazon and Microsoft and others. So this huge assembly of systems, assembly of networks, assembly of IoT companies together, they are very active, they are agile, and they offer you services of all kinds, which help you in your smart city. How does an IoT system work? Now, if you see the slide, there are a number of names. These are the companies which do IoT system work, such as IBM, such as Google, PTC, Cisco, ARM, Intel, Microsoft, Apple, Bosch, and SoftBank. There are many others as well. But these are the large, very large companies, and they perform IoT system work. What does happen at an IoT company? The IoT company is connected again with a hub or an IoT gateway. So you know this is system of systems. An IoT, an individual IoT company rely on data which is coming from sensors. And the sensors are placed in devices. And these devices have antennas. Antennas transmit the data, and the data reaches IoT company. These, of course, these devices are fitted with microcontrollers, and these microcontrollers do the job. Now, this IoT hub gets back to you, and they use interface, smartphones, or human-machine interactions. And they perform analytics of business applications, customer relationship management, that is called ERP. And they provide backend systems. See, this is how 55.3 million people are busy at work. Are you one of them? That is the question. Some of us are, but many are not. Let's come back to basic terminologies. Let's come back to basic terminologies. I think we have to keep people along so that they know what we are talking about. This is the right time we get into this activity, make use of this activity, and instead of awarding projects to foreign companies, we should award projects to our local companies, our local engineers and ICT specialists. There are quite a number of them. They are there in Pakistan. They should get together and utilize their services and get employed with companies, local companies, who can participate and set their cities as smart cities, instead of awarding contracts to outside consultants, outside companies, and importing all the time. I think we need to make a break and develop our indigenous resources, develop our people, our engineers, our ICT specialists, bring them together into groups, together into companies who should be doing the work really, instead of foreigners. This is the right time. This is a new subject, a new technology, and not really very new, but we all know a little bit about it. Some of them know more, some of us know a little less, but we are already in touch. Everyone who has a smartphone, I think, has a realization of how things happen, where the data comes from, how they know where you are. Let's come to the basic technologies again. We really very down to earth basic technology, the basic terminologies. We just go through these basic terminologies so that people who are not much aware of this domain, they are at ease, that they feel comfortable. Connected devices. So we talk of these connected devices. What are these connected devices really? Connected devices are physical objects that can connect with each other and other systems via internet. So physical devices. Your smart mobile is a physical device. Physical device, camera, a smart camera set on a traffic crossing may be a physical device. These physical devices, they span everything from traditional computing hardware, such as a laptop or desktop, to common mobile devices, such as smartphone or tablet, to an increasingly wide range of physical devices and objects. Now, in these connected devices, there are sensors. What is a sensor in an IoT device? These sensors are there in IoT devices, and they play a very important role. And they connect you with IoT. Sensors are devices that detect external information, replace it with a signal that humans and machines can distinguish. So the external information is received, and it is translated into transmission language in which electronic signals can be transmitted. What is a connected device platform? We have already talked about these platforms, and let's really repeat. So what do we mean by a connected device platform? A connected device platform is a software solution that unifies and simplifies the management of connected devices and software. Connected devices platforms can support IoT ecosystems. This is called ecosystem. This is called IoT ecosystem, Internet of Things ecosystem. That is a whole system, or like it's a system of systems really. And a connected device platform is one which is connected with devices, and devices are transmitting signals, and then these connected device platforms have both hardware and software, and it handles, processes this information, and it gives results to people who want particular results. So bringing information in, processing it, and supplying it to whoever wants. This is the working of the platform. Now, how do I connect my internet to an IoT? Now, first step is to hop in IoT communication. It is either wired or wireless. Mostly it is wireless these days. You hop into it. That means you register yourself into it. This is really, you connect yourself with a serial protocol through a networking system like Ethernet or Internet, direct Internet services. This is called TCP/IP. This is a protocol, and it connects you to a network server and to a cloud application. What is the criteria that qualifies you as an IoT device? Is your mobile phone an IoT device? That's the question. Good question. Is your mobile phone an IoT device? As long as the device is able to connect to the internet and has sensors that transmit data, it can be considered as an IoT device. And although your smartphone can do both, it's not an IoT device unless it has a transmitter. It can transmit data. Now, these IoT companies, and they work in hubs, they have protocols. Protocols means way of action, or these are basically softwares handling this information and transmitting. IoT protocols, we can give some examples of what IoT protocols exist. Message queuing, telemetry transport, MQTT. It's a very common and frequently used protocol. Then there is a protocol called Zigbee. Bluetooth is also a protocol. You know, on your smart iPhone, Bluetooth services are there. Wi-Fi is there. Wi-Fi is also a protocol. Extensible Messaging and Presence Protocol. This is XMPP. Data Distribution Services, DDS, Advanced Message Queuing Protocol, AMQP, lightweight M2M, LWM2M protocol. These protocols are software which are developed by ICT companies, and they are used by IoT companies for their operations. Like LWM2M. LWM2M is lightweight protocol. It is used for housing, traffic management, or remote construction management. Then MQTT, message queuing telemetry transport. MQTT is used for street lights and for surveillance. Then there is a protocol called COAP. This protocol is used for managing energy sources and for environmental surveillance. DDS, which is Data Distribution Service, is used for monitoring weather, pressure, temperature, rainfall. So these are protocols. These are already registered. They are already developed. They are already in use by IoT companies. What are IoT applications that we are talking of, really? These IoT apps you can call it applications. In short, you call it apps. These apps run on IoT devices and can be created to be specific to almost every industry and vertical, including healthcare, industrial automation, smart homes and buildings, automotive and wearable technology. Increasingly, IoT applications are using AI and machine learning to add intelligence to devices. ये हमाद साहब कुछ कमेंट्स इकट्ठे हो गए हैं. 10 of them I can see from here. इनको आप जरा हैंडल करें. और जो वेटिंग रूम है उसमें भी कुछ लोग हैं जो एंटर होना चाह रहे हैं. वेटिंग रूम को भी आप हैंडल करें. We were talking of apps, IoT apps. These IoT apps are available. You can register yourself there. You can avail these softwares, and they will provide you IoT applications, connected appliances. You can connect your appliances into IoT and get your desired function performed. Such as smart home security systems. I think virtually we know, many of us know what smart home security systems are there. You can avail them in your homes, in your houses, in your factories, in your offices. And anytime a door opens, there is an alarm, and you get an audio signal that such and such door has been opened, so forth and so forth and so forth. Then autonomous farming equipment. You can you can have farming equipment and apply smart IoT apps on them, so that you can watch the functioning of this equipment, the farming equipment, from a remote place, from your smartphone. You can see how your tractors are running, where they are parked, how much of them are in use. Wearable health monitors. So as you know, you have a wrist watch like a thing. You wear it on your wrist. It captures your blood pressure, your temperature, and even it performs your blood checks, blood tests, oxygen level, and all this data it is transmitted to a central health monitoring system, and maybe you can engage a physician who can look at your data and give you health advice. All this can be done while you are staying home. Then smart factory equipment, again, you can fix these devices on factory equipment, from which you can get data transmitted to an IoT company. An IoT company refers back to you in your smart mobile. From smart mobile, you can check and see in your factory what equipment is being used, what is not used, and how it is performing. It depends, what kind of sensors you install on this equipment. So this is the technology of today. Then there are inventory trackers. You can do really smart inventory services, so readily available. Then there is a special service which an IoT company will offer you: ultra high speed wireless internet. Sometimes when you are handling large data and you don't want it to get corrupt, ordinary speed doesn't really do much good. You need to have ultra high speed. So an IoT company can provide you ultra high speed wireless internet as well. Then there is another service, that is the biometric cybersecurity scanners. The biometric cybersecurity scanner is a service which an IoT company provides you, by which you have biometric scanners. Anybody comes and it enters into your premises, you can scan his identity, and you can learn, his background, a lot of information about him as far as security is concerned. So these IoT companies, they give you a lot of information. The applications are already set there in IoT companies. You really don't have to do much about it. You just register yourself there, and you'll be a user, an accepted user. And you can choose whichever service you really need. You will get services like connected vehicles, especially these days, autonomous vehicles are coming. So autonomous vehicles are those which are driverless vehicles, and they can be connected to an IoT application, and they are connected vehicles. These connected vehicle services are already, I think, they are used by services like Uber. You have a smartphone and you have an app for Uber, and you can really call for an Uber, and you can see where the nearest Uber is and what time is going to approach to be with you, and it is already there. You see, you are already using the service. Then IoT company also offers traffic management. Traffic management means traffic analysis, maybe crossing signs, connected crossing signs, signals, and connected cameras, traffic cameras. Then it provides the smart grids, environmental monitoring, smart buildings, smart homes. These services are already available. I mean, even individuals can get smart home services in their houses, in their homes, in their offices, in their factories. Similarly, when it goes on a bigger scale, smart cities. These smart cities services are offered by these IoT companies. So you just simply have to register and make use of that. Another very big, very wide application is supply chain management. The supply chain management services are there. You need to hook yourself into it, and on your smart iPhone, you can see where the parcel is coming, how long it's going to take for arrival at your place, and you can track. You can track the supply chain, and the services are already there. I mean, many of us are already using these. Then industrial, agricultural, and commercial management services. Many of us who are running their factories, maybe running their offices, they can use these services for management and control, and incoming, outgoing, monitoring, fiscal monitoring as well. So all this is there. Many of us are already using these services. These are apps, they are available. People are ready, people are working. And all you need is to hook yourself into it. Maybe presently, many of us are already utilizing these services on individual level. But a smart city itself has to do it on an administrative level, on a public level. So that is the only difference. Unless there is nothing rocket science anymore. It is not a rocket science anymore. The services are available. The companies are there. Your internet takes you to all these platforms, and the platforms are connected to IoT. So it's all right there in the plate. Technology framework for smart city solutions. There are two kinds. One is on premises or remotely connected. Then another segment is on premises or through a cloud. Two options: wide area network, local area network. Local area network is not so common, but it's very important. Sometimes, you like to stay within your factory, and you can do all this within your factory, and so that other factories don't look at your data, your happenings. But you can utilize the wide area network, and in that situation, if you're running a factory or an office or a smart city, really, you can make use of data comparison. I mean, if you have the figures of the traffic accidents in your city, you can compare it with the accidents per capita, maybe per 1,000 people in other cities, maybe in Delhi or Singapore, other places. So how do they work? We have already talked about all this. How does all this work? It starts from your devices, and devices have sensors, and information is communicated from devices, the sensors in the devices, to gateways, and the information is communicated to platforms. And in platforms, there are applications. And say, for example, there's a smart city application. So the smart city applications, the work is really done at data centers, as we have already talked about. And you need to get into an IT, OT applications together. So you have a system of information technology connected with operational technology, and all this is IoT, information of Internet of Things. With the use of this IoT, you can run your systems, you can transmit data, people will be there to process this data, and they will inform you the decisions or the findings in the way you like it. Maybe you like it in a graphical form, or you like it in a bulleted form. So you will receive this information on which you can take decisions. This is already there. I mean, the software houses, the IoT houses are already there. You need to tag yourself in and run maybe your factory, maybe your house, maybe your office, or maybe a city itself. City is a big level, but technology is there to handle these data, millions of bytes and millions of data. This is not a rocket science anymore. We have been talking of this IEP and OT before, and information technology and operational technology. This has joined hand to hand, really. And what is the role of information technology, IT, and operational technology, OT, in IoT project development? Information of things, that is IoT. This information of things have to, it has to run on the basis of your IT and also OT. So the line between traditional operational technology systems and the information technology system has been blurred, has been merged into one. The IoT brings the ability to connect devices, systems, and applications to create a flexible, interpolable, operable environment that includes components from the smallest devices to the largest data centers. This is already set. This is already there, and systems have been developed, and these are accessible. So we need to really get familiar with them. We need to be acquainted with them, and we need to see how this can be used for your maybe home management, maybe your office, maybe your factory, or your smart city. Now we have IT on the left hand and OT on the right hand, and when it is combined together, integrated together, we call it convergence. So it is really IT and OT convergence, convergence of information technology and operational technology, which builds itself into IoT, that is called Internet of Things. IT systems are used for data centering computing, and OT systems are used for monitoring events, processes, and devices, and making adjustments in enterprise and industrial operations. The Internet of Things, IoT, has changed the landscape of the energy industry. IP-enabled networks connect the operational technology, OT side, and the utility and information technology side. This means a convergence between SCADA, AMI, DA, and consumer engagement systems. Now, how to facilitate the convergence of IT and OT? These are the steps, 5 steps. Communicate the goals, create an IT/OT roadmap, define roles and responsibilities, cross-train IT and OT teams, provide the right tools. This is the roadmap. You don't have to do this really. This is already done. These IoT companies have already established these systems. You need to really hook yourself up into these systems. But in order to really have a feel that how have they done, how have they facilitated convergence of IT with OT? These are the slides which I like to show to you, just to give a glimpse of how these IoT companies have prepared all this for you. System is there. You really don't have to invent the wheel. You have to use the wheel. OT really involves sensors, machines, and assets. Like a loudspeaker system, maybe a lathe machine, a smart lathe machine, and other sensors fitted in devices. Then these devices need to be connected through routers, switching, protocol convergence, and protocol support. This is a network infrastructure tier. This is OT. Now this OT is connected to IT. What does IT do? IT has connected networks, CPUs, OSS, and cloud agents, and platforms, and apps. The apps some of the apps are already there on your smartphones. And these data centers, these hubs, IoT companies do all this job for you. What is an IT OT network? I think we have already talked quite a lot about it. And a smart city is the integration. The smart city is in fact an integration of IT and OT. As you see, this purple circle and there is a blue circle, and combined together, there is a common area where smart city develops. OT is machines, equipment, controls, monitoring, devices fitted with sensors, transmitting information. Information is transmitted through IT. And IT does computing, it does storage, it does infrastructure, networking, data processing, and analysis. So digital innovation requires operational technology systems to interact with information technology systems. OT network components like control systems such as SCADA and smart city networks are being connected to IT network components such as processors, storage, and system management. Hamad साहब फिर अब ये चैट रूम में देखें, there are 16 comments from people. आप इनको जरा हैंडल करें. वो कमेंट्स देखें क्या है.
जी सर, रिप्लाई कर रहा हूँ मैं साथ.
ठीक है. As we have talked about these IoT companies and the hubs, and where do they get technology from? They get technology from certain technology enablers. And technology enablers are really regulatory bodies. They include governments, regulatory bodies, other organizations. They facilitate technology adoption through standards, guidelines, policies, funding, and investments. Guidelines and standards, regulatory framework is really provided by, say, a technology enabler. The role of a technology enabler is to act across one or more layers of the smart cities technology framework and create an end-to-end value for users of the smart cities ecosystem. Technology enablers can be further categorized into classes depending on the primary part of the framework in which they act upon. So there is a classification. There are categories of enablers. These technology enablers who work for the IoT companies, giving them bases, giving them rules, and giving them regulations. They are categorized. There are kinds of enablers. One kind is a digital enabler. What is a digital enabler? As an ecosystem platform, digital enabler enables new data economy business models, fostering innovation and enhancing current capabilities. A digital enabler should be used wherever data needs to be enriched तो enrichment जहाँ पर जरूरत होती है, ये digital enabler आपको काम आता है. There are other kinds of enablers too. This is just for your knowledge, for your information, that how IoT companies work. From where do they enable? From where do they enable themselves? Digital enablers. We have access enablers. Their function is just to provide access. What they do is privacy and security controls. It's a very important aspect. How privacy is respected and maintained. How security controls are done, because hacking takes place. Hacking has been taking place quite frequently, but the controls have really limited all these hacking to a great degree. But as you know, I remember 2-3 days ago, there was a hacking done on our National Bank of Pakistan. National Bank of Pakistan account system was hacked. Do you remember this? It was in the news, and for I think it took about 24 hours before National Bank of Pakistan got over it and started functioning again. Or I think one complete 24 hours, National Bank of Pakistan went out of function. So these security lapses take place sometimes, and in order to control these security lapses, these access enablers come into action. Then these access enablers also provide the geolocation services. Geolocation services are like Google Earth. As you see, Google Earth is a computing platform. Google Earth, we are quite familiar with this. I think Google Maps, almost all of us very frequently get into these location. They need to locate the place where they are heading to, or they need directions, and Google Earth is made use of. And the Google Earth is a computing platform, and it runs on a geospatial analysis. Again, this takes place at some of their data centers. And I have a figure of 1,100 full-time employees. 1,100 full-time employees work at geospatial analysis today. Software is already there. It works on GIS. Software is there. It runs automatically. But still they need people. They need full-time employees. There are 1,100 employees working in Google Earth. And I have seen that there are, in addition to full-time employees, there are 6,000 contracting companies they have engaged. So 6,000 contracting companies are presently working from all over the world to support the services provided by Google Earth. I wonder how many of these outside contractors and full-time employees are from Pakistan. I wonder how much is the share that Pakistani ICT specialists and engineers contribute into Google Earth services. this is a matter of concern. It's a matter of concern that how much of this activity is shared by us. Then let's go further. There is another services which these access enablers provide you, that is context awareness services. When you ask for a context awareness services, that means you let these access enablers work out for you what is the right context and where to get information from that is relevant to your inquiry. So this kind of services are given by access enablers. Then these access enablers also provide you enhanced crowd-sourced data. Enhanced crowd-sourced data is really these are clouds. The huge mega magnitude data is handled by this is called the clouds of cloud. Clouds of clouds is a crowd-sourced data which is necessary for Internet of Things operations. So these IoT companies engage access enablers to provide them crowd-sourced data. Then there are platform enablers. These platform enablers also are there to work for IoT companies, and they provide support services to IoT companies. These platform enablers support the distribution, management, exchange, integration of data and services. Somebody is asking for just 1 second. All right. So these platform enablers, they support the distribution, management, exchange, and integration of data services. They run the services of advanced analytics, artificial intelligence, machine learning, and they also provide the data integration platforms and data exchanges, augmented reality, virtual reality platforms. So this is how they have all got down together, they work together, and they enable you to IoT services. In addition, there are application enablers. Application enablers really provide apps. And they are promoters and developers of apps and application program interfaces. Apps and marketplaces, AR, VR content, evolution of content ecosystem. Now, other than these enablers, there are infrastructural enablers. These infrastructural enablers really provide improved means to manage and protect city and citizens' assets. They will protect your assets, the digital assets that you provide to them. And you need these infrastructural enablers. You don't need them really. The IoT companies need them for enhanced management, asset management, enhanced preparedness, enhanced resilience. So we are now focusing towards smart city applications framework. As we have talked before as well, the smart city has to run such smart operations as visible on the screen here: education, public safety, healthcare, government services, tourism and economic development, citizen engagement, transportation, energy, smart buildings, water and wastewater, and waste management, and many others as well. These smart city platforms include management of connected devices plus the management and enablement of services to support applications. In this sense, platforms can be viewed as the combination of connected device platforms and application enablement platforms, it is CDP and AEP, or CDP, AEP together. This is a significant opportunity in terms of how municipal infrastructure has been deployed and managed in the past. Conventional supervisory control and data acquisition, that is called SCADA. I think SCADA is quite familiar to our engineers to some extent and to our ICT people. SCADA is supervisory control and data acquisition. That is a system which is very frequently used. In addition, often used are databases for monitoring, management, and control. Analytics are done in large proprietary and expensive backends. Other small city platforms in use are Cisco, Kinetic for Cities. This is a specific platform for a smart city. Platform is already there. Cisco platform is there. You don't need to invent it. You need to get registered, really. The work has already been done. They are already connected together. They have the software. They have the ability. They have the enablement. All you need is to get connected, get registered. Of course, you need to pay a premium for it. Then, in addition to Cisco, we have InterDigital's Cordant, Huawei's Ocean Connect, PTC's ThingsWorks, Nokia Impact, Silver Springs Networks, ITRON, SLV, ZTE, Smart Street, Fiverr Smart City platform, and ArcGIS supported GIS and GPS. Now, I think I have already sent these slides to all our registered participants by email. You got all these slides in your email. I think after this workshop, maybe you have plenty of time, and if you spare time to go through these slides, I think this will be a convenient and a simple introduction to how these smart devices work and how devices are connected to platforms and what facilities are provided to these platforms in respect to management of a smart city. We have talked about this before as well, so this is kind of a repetition. What is connected device platform? If you go through this workshop, I expect you will be familiar with these terms, and when you appear for an interview, maybe people who like to set up a smart city at the places, maybe in Sahiwal, Sialkot, Gujranwala, other places. So when you appear an interview for an appointment, you will be a better known person. You will talk in confidence, and I think this is a future for employment to a great extent, provided you have training and familiarity and a kind of a competence. You don't have to invent the wheel, really. The facilities are already there. The apps are there. The platforms are there. And all you need is to be familiar with it, how you get registered into it, and how you can be a useful person in a smart city management and administration. Coming back here, it's really a repetition. What is connected device platform? It is a connected devices platform service, CDP-SDC, is a relatively new service that was introduced into the later versions of Windows. You see, it is a part of Windows. It is already there. The connection with these sort of devices was also possible in the previous versions of Windows, where the service didn't exist. Previously, if people who have a old version of Windows, they will not see this. But people who have the latest versions of Windows, they will see that this platform is already, this app is already present in Windows. A connected devices platform is a software solution that unifies and simplifies the management of connected devices and software. Connected devices platforms can support IoT ecosystems. You need this app to be able to perform IoT ecosystem services. You don't really have to provide, you don't have to work these services yourself. You need to be a member in an IoT company. The IoT company will provide you all this support facility for you to be able to do work in a smart city. It is associated with Bluetooth, printers and scanners, as well as in music players, storage devices, mobile phones, cameras, and many other places of connected devices. It provides a way for devices such as PCs and smartphones to discover and send messages between and each other. What is an application enablement platform? We have already talked about it. So this is a kind of a repetition. An application enablement platform in the context of this article is a software product. It is a software product with foundation level capabilities that are used by a team of developers to build a consumable software application. You have work to do to get to an operational. What is an AEP in networking? AEP, Application Enablement Platform. Application Enablement Platform networks provides service communications and network application access for government, enterprises, service providers, markets. AEP works with systems integrators, managed service providers, and the distribution channels to deliver integrated solutions. And as you see, this is already there in the latest version of Windows. What is SCADA? SCADA is quite familiar to our engineers, especially engineers who work in infrastructure and ICT people as well. SCADA is very popular, it's very common, it is available. This is a supervisory control and data acquisition system. This is called SCADA. SCADA is a computer-based system for gathering and analyzing real-time data to monitor and control equipment that deals with critical and time-sensitive materials or events. Supervisory control and data acquisition system, SCADA, is a system of software and hardware elements that allows industrial organizations to directly interact with devices such as sensors, valves, pumps, motors, and more through human-machine interface software and record events into a log file. So SCADA will detect sensors that are fitted in your equipment, valves, pumps, motors, cameras, maybe, and they catch the signals and process it and give you results in a log file. SCADA systems are used to control and monitor physical processes. Physical processes I didn't go to the monitor SCADA. Or examples इसकी क्या है? The examples are transmission of electricity. For transmission of electricity to control and monitor, SCADA is there. Transportation of gas and oil in pipelines. You see how powerful SCADA is. You don't need to invent SCADA. You don't need to develop any software. All you need is to get registered as a user in SCADA and avail the software and hardware services that SCADA provides as a platform. It will monitor and it will control your transportation of gas and oil in pipelines. It will monitor and it will control the water distribution services. It will monitor and control traffic lights and many other utilities that are the basis of a modern society. The SCADA already there, SCADA is already there, the platform is there. All you need is to hook yourself up into it. Maybe not individually, maybe a smart city office will get a membership, will get itself registered, and maybe you are using SCADA for the operations management of the smart city. The work which has been awarded to Surbana Jurong, a Singapore company, for developing a smart city of Lahore. Lahore smart city, the work has been allocated as far as town planning is concerned. But there is a huge lot of work if the smart city of Lahore smart city wants to run their operations as a smart city in a real term. And they will require people, if they really want to do what they claim, if they really want to run the city as a smart city, they will need people trained how to use SCADA, trained as to how to use other smart city platforms as IoT system. They need to establish IoT system in their smart cities, and not only Lahore, but in Sahiwal that is to come, maybe Sialkot and Faisalabad, as planning commission is already announced that they are going to introduce small city practices in the other cities as well. As I have already told you, there are 174 small cities, the smart cities working at the moment all over the world. So we are in it. Smart cities are coming, and we need to be prepared for it. We need to get trained. We need to be aware. We need to get familiar. So this slide, as you see, gives you how SCADA performs. It's a wireless communication system, and for this, there is a really there's a huge build of databases, and that is a SCADA primary database. Then there is SCADA HMI primary, then SCADA HMI secondary, then SCADA secondary database. These 4 databases are really they do it themselves as LAN. Now then they are connected. There are wireless long haul communication. Now communication runs on 2 levels. One is a satellite communication, and the other one is cellular radio communication. Both communication systems work in SCADA. Then they touch your gateways, PLC, RTU gateways. These gateways are connected to your device, connected to your maybe laptop, to your computer where internet is there, and connected to your iPhones. And what they do really is they catch your sensors. Sensors are placed on your pipelines maybe, and they will get the data for the flow rate, and sensors may be there on your reservoirs, on your tanks, water tanks, and sensors are there which are measuring temperature, measuring humidity, environmental sensors. They all collect data and transmit them to SCADA hub, and the SCADA performs these services, and the control and monitoring is done, and they get back to you and they tell you how the system is running and how to control it, how to monitor. This is supervisory control and data acquisition, that is called SCADA. SCADA is a system of software and hardware elements that allows industrial organizations, maybe city organizations as well, for controlling and monitoring processes in real time from remote locations. Analyze and calculate complexity of processes and maintain accordingly the control signals. Data acquisition, historical data logging, archiving, and retrieving, trend and alarm generation, recipe management for process and chemical industry, report generation. And all this is done by SCADA. You don't need to get into how they work. You only need to avail of it. Like if you're driving your car, all you need is to know how you drive a car. You don't really need to go into your petrol transmission, how the brakes work, how the clutch works. Or you don't need to open the engine and dismantle it and reassemble it again. You don't need to be a mechanic to drive a car. You don't need to be a mechanical engineer to drive a car. Similarly, if you're using SCADA, you don't really need to get into the bottom of it. You already all you need is to be able to use SCADA, and that is not difficult at all. Maybe those specialists of ICT and OT who like to get into the development part of it, they can also be employed by SCADA, the SCADA platform. They can be working. I mean, if what figures I have for IoT development companies, 6.2 million development companies are operating at the moment all over the world. And there are 620 IoT platforms working at the moment all over the world. So you may be working for them as well. It's a matter of get yourself training. It's a matter of getting a competency and getting employment. I am happy that we are on the 4th floor of the Institution of Engineers Headquarter building, and we have made a center there, technology center there. It is an innovation and incubation training center, and this is perhaps the first time that this room that you are in physically, that we are doing this course. This is the first course, maybe. क्यों हमाद साहब, ये फर्स्ट कोर्स है आपका 4th फ्लोर पे? हमाद साहब
जी सर, 4th फ्लोर।
4th फ्लोर पे ये फर्स्ट कोर्स है
जी, सॉरी,
ये फर्स्ट टाइम है? फर्स्ट टाइम आप 4th फ्लोर पे?
ग्राउंड फ्लोर है सर।
आप ग्राउंड फ्लोर पे?
जी सर, आईपी हेडक्वार्टर ग्राउंड फ्लोर पे और ये इंक्यूबेशन सेंटर 4th फ्लोर पे है।
4th फ्लोर। तो हमने ये इंक्यूबेशन सेंटर जो है 4th फ्लोर पे इसलिए कायम किया है कि हम ट्रेनिंग सेशन करें और एप्लीकेशंस जो है वो सारी वर्ल्ड ओवर से लेके आए और वहाँ पर लोगों को इंट्रोड्यूस करें। तो जो ये एप्लीकेशन है ये स्कैडा है, एंड स्कैडा वर्क्स ब्यूटीफुली, इलेक्ट्रिक पावर सिस्टम्स ऑपरेशन एंड कंट्रोल। SCADA systems are used in electric power generation plants, transmission areas, and distribution systems. Where SCADA is used in manufacturing industries of plants. SCADA helps in management of different inventory items or raw materials, controlling of automatic systems and synchronous manners. Telecom and IT-based systems, management of different RF-based systems, communication mediums, and large communication systems, including data logging through antennas, can be easily done through the SCADA. So maybe we can hold another training course, especially for the use of SCADA. One time or the next time maybe. Water and sewage treatment plants and supply management. SCADA-based systems are used by the state or municipal corporation to monitor, control, and regulate water capacity in reservoirs. ये कुछ फर्दर एप्लीकेशन है स्कैडा की। इंस्टीट्यूशन ऑफ इंजीनियर्स पाकिस्तान का काम है, ये इनकी जॉब है। इंस्टीट्यूशन ऑफ इंजीनियर्स पाकिस्तान का मकसद है टू transfer technologies, train people, enable them to use the modern technologies in their profession. ये उनका काम है और we need to do this. We have all the intention to do this, and I think this is the right time. ये जो smart cities की technologies है, we should get familiar with them and we should get trained into these technologies. तो मेरा ख्याल है कि एप्लीकेशन जब स्कैडा है उसको देखे कहाँ कहाँ ये अप्लाई होती है. It's applied to traffic controls. SCADA helps in regulation of traffic signals, controls the traffic flows, railway systems, road systems, air traffic controls. SCADA तो एक यूनिवर्सल जैसी प्लेटफॉर्म है, हर तरह आपके काम आता है. लिफ्ट एंड एलिवेटर कंट्रोल, ये जो एलिवेटर्स और लिफ्ट पे कंट्रोल चलते हैं, ये भी SCADA के ऊपर चलते हैं. Buildings and facilities and environments. Facility managers use SCADA to control heating, ventilation, air conditioning systems, refrigeration units, lighting and entry systems, mass transit and railway traction systems. ये भी SCADA हैंडल करता है. SCADA at marketplace. डाटा प्रोवाइड होता है SCADA को, आपने डाटा उसको प्रोवाइड करना, खुद से तो उसको पता नहीं लगेगा. स्मार्ट सिटी डाटा एक्सचेंज एंड मार्केटप्लेस, वो इंटरफेसेस पे काम होता है. There are technical interface, then there are commercial interface, then there is a legal interface. ये सारे चैप्टर्स हैं SCADA के अंदर, और एनालिटिक्स वहाँ पे काम करते हैं. ये डाटा सेंटर्स पे काम हो रहा है. एनहांसर्स हैं, वो रॉ वैल्यू को वैल्यू ऐड करके देते हैं, कंज्यूमर्स को वैल्यू ऐड करते हैं और सर्विस प्रोवाइड करते हैं. डाटा ड्रिवन स्मार्ट सिटी सर्विस प्रोवाइडर्स, वेयर यू आर. और SCADA को इस्तेमाल करना कोई इट्स नॉट डिफिकल्ट. ये हमारे जो नौजवान हैं बहुत इजीली ये काम कर सकते. सिक्योरिटी का मसला होता है व्हेन डाटा ट्रांसफर होता है एक जगह से दूसरी जगह और वापस आता है, और आपके इसको मॉनिटर और कंट्रोल के लिए इस्तेमाल करना होता है. तो सिक्योरिटी, डाटा की सिक्योरिटी इज ए क्वेश्चन, बिग क्वेश्चन. उसके लिए एक ऐप है, ऐप ID सिक्योरिटी रजिस्ट्री. तो ऐप ID सिक्योरिटी रजिस्ट्री जो है वो भी एक प्लेटफॉर्म है जहाँ पर लोग काम कर रहे हैं, और वो आपको सिक्योरिटी रजिस्ट्री प्रोवाइड कर रहे हैं. An IoT app ID security registry can provide a central trusted repository of IoT application, identifies and profiles to enable IoT platforms to identify and authenticate IoT device application data from known trusted sources through an automated process. ये आप देख रहे हैं कि ये बोतल में जिन है जो कि बोतल में बंद कर दिया गया है, और जिन को बोतल में से निकालना आपका काम है. उस जिन ने काम करना है, आपने सिर्फ बटन इस्तेमाल करने हैं आपके कीबोर्ड के, और वो आईफोन पे तो बटन भी नहीं होते. जिन तो ऑलरेडी बन चुका है, ये तो डेवलप हो गया है, और भी डेवलपमेंट इसमें हो रही है. बट यू कैन ऑल्सो ज्वाइन एंड help them for further development. But for normal work, you don't need to get into all this processes and details. All you need is register yourself and use this. And this is a security registry जो कि आपको जरूरत पड़ेगी. The IoT App ID Security Registry provides virtual trust between IoT platforms. ये IoT platforms जब आपस में काम करते हैं तो इंफॉर्मेशन आया ट्रस्टेड है या अनट्रस्टवर्दी है, इसको देखना ये सिक्योरिटी रजिस्ट्री ऐप का काम है. Such a registry provides the foundation of IoT security across the ecosystem for all stakeholders and ensures that IoT applications and the data they produce can be trusted. This will facilitate the sharing and commercialization of IoT data while protecting consumer privacy, importantly for smart city marketplace delivery. ये है इसका तरीका डायग्रामेटिकली कि ये प्लेटफॉर्म्स के दरमियान इंफॉर्मेशन जो कम्युनिकेट हो रही है उसको ट्रस्ट आप कर सकते हैं. अननोन है, अनकंट्रोल्ड डिवाइसेस से आ रही है या नोन और कंट्रोल्ड डिवाइसेस से आ रही है. ये कुछ एग्जांपल्स हैं यहाँ पर स्मार्ट सिटी मैनेजमेंट सिस्टम की एग्जांपल्स है. एक सिस्टम है एसेट मैनेजमेंट सिस्टम. ये स्मार्ट सिटी के अंदर जितने एसेट्स है, प्राइवेट है या पब्लिक है, उनको मैनेज करने के लिए ये सिस्टम है. देन वी हैव an emergency preparedness system. इमरजेंसी मैनेजमेंट सिस्टम है, उसको कैसे फंक्शन करना है, कैसे उसको चलाना है. So this system based on situational data, shared data resources, predictive analytics, and context awareness. Then in transportation, in IoT companies, they have technology enablers, 5G, edge computing, gateways, geolocation services, context awareness services, advanced analytics, AR platforms. ये जो platforms है, ये क्या करते हैं? ट्रांसपोर्टेशन को कंट्रोल और मॉनिटर करते हैं. सड़कों पे जो ट्रैफिक है उसको मॉनिटर करते हैं और कंट्रोल करते हैं गेटवेज के जरिए, डिवाइसेस के जरिए, सेंसर्स के जरिए. ये स्मार्ट ट्रांसपोर्टेशन सिस्टम है जो कि जैसे वर्क करता है. देन वी हैव एनर्जी कंट्रोल एंड मैनेजमेंट सर्विसेज. इसके जो टेक्नोलॉजी एनेबलर्स है वो ये काम करते हैं. देयर इज अ कंट्रोल सेंटर जो कि टू वे कंट्रोल्स है, जहाँ से रिसोर्सेज है जो इधर जहाँ से पैदा होती है और जहाँ पे यूज होती है, फैक्ट्रीज, बिल्डिंग्स, पब्लिक फैसिलिटीज. They are all integrated together. This is how smart city energy management system works. फिर है हमारे पास स्मार्ट लाइटिंग एंड स्मार्ट बिल्डिंग सिस्टम. खंभों के ऊपर जो लाइट्स है, कब ऑन होनी है, कब ऑफ होनी है, कितनी लाइट कहाँ पे होनी है, वो जो ट्रैफिक उधर से फ्लो कर रहा है, वहाँ के जो सेंसर्स हैं वो पिकअप कर रहे हैं ट्रैफिक डाटा और डिवाइसेस की तरफ भेज रहे हैं एंड द सिस्टम एनालाइजेस देम, और फिर आपको ये जो ट्रैफिक लाइट्स है इनको कंट्रोल करते हैं. स्ट्रीट लाइट मैनेजमेंट फॉर स्मार्ट सिटी, इसको ये कहते हैं. देन वी हैव हेल्थ केयर मॉनिटरिंग एंड कंट्रोल सिस्टम. हेल्थ केयर में जो पेशेंट है वो डाटा थ्रू इट्स आईफोन ट्रांसमिट करता है. वो डाटा सेंसर जो है वो उसकी रिस्ट वॉच के ऊपर सेंसर लगे हुए, वो डाटा ट्रांसमिट होता है डाटा सेंटर के में, फिर फीडबैक होता है टू फिजिशियन जो है उसको आप एनालाइज करेगा और आपको डायग्नोस करेगा, और इस तरह ये हेल्थ केयर सेंटर में काम होता है। स्मार्ट सिटी हेल्थ केयर सिस्टम है। फिर आपके पास सिटीजन एंगेजमेंट, टूरिज्म एंड इकोनॉमिक डेवलपमेंट सिस्टम, ये एप्स हैं जो कि ऑलरेडी फंक्शन कर रही है ऑल ओवर द वर्ल्ड। We need to get registered into these functions and make use of them. Citizens engagement, tourism and economic development. Then we have a public safety system, driver behavior, engage citizens, digitize detection, monitor real time, act instantly. कहाँ कहाँ गाड़ियाँ खराब हो रही हैं, किधर आपने इसको भेजना है सर्विसेज को। ट्रैफिक इंसिडेंट मैनेजमेंट फॉर स्मार्ट सिटी। एजुकेशन में भी, एजुकेशन सिटी क्लाउड है, ह्यूज data information is already there. So टीचर और स्टूडेंट्स के दरमियान तल्लुक है, इसको क्लाउड के जरिए आप ऑपरेट करते हैं। Then we have government services, access to citizen-centric government services. Then water management services. The water management system. All these slides, I have provided all these slides to you through your emails. So आप कोई spare time में go through हो again, और फिर आप अपने आप को acquaint करें, अपने आप को familiarize करें और get ready करें कि turn your cities into smart cities में आपने क्या रोल प्ले करना है। वेस्ट मैनेजमेंट स्मार्ट सिटी सिस्टम है, वेस्ट को कैसे मैनेज करना है। इवन जो बिन्स हैं, ट्रैश बिन्स जो है, इनके अंदर भी सेंसर्स लगे होते हैं कि कौन सा भरा हुआ है, कहाँ से कूड़ा उठाना है, कौन से ट्रक्स को किधर भेजना है। ये सब स्मार्ट सिटी का काम है और वी आर ऑन ए डेवलपमेंट पाथ। ये तो सिस्टम पाकिस्तान में आए ही आए, ऑलमोस्ट आ ही गए हैं। आप ये सब आपके आईफोन के ऊपर ये सिस्टम अवेलेबल। ऑल यू नीड टू डू इज योर कंट्रीब्यूशन इनटू इट। तो मेरा ख्याल है कि अब टाइम भी हो गया है और मुझे आपका शुक्रिया अदा करना है। तो क्यों हमाद साहब इसको कंक्लूड कर दें। है हमारे पास ख्वाजा वहीद साहब है।
सर चले गए हैं ख्वाजा साहब,
वो चले गए। अब शेख साहब है।
शेख साहब भी सर अभी गए हैं, 10 मिनट हुए, वो
भी अभी गए हैं। तो चलिए ठीक है, जितने इस वक्त लोग हैं मैं सबका शुक्रिया अदा करता हूँ और इसको मैं क्लोज करता हूँ और मैं आपको से इजाज़त लेता हूँ। सो वी होप टू सी यू नेक्स्ट टाइम, maybe on a specific topic. We have another course soon. Allah Hafiz. Allah Hafiz.
अल्लाह हाफिज। बहुत बहुत शुक्रिया।
अल्लाह हाफिज। बहुत शुक्रिया डॉक्टर साहब।
शुक्रिया जी, थैंक यू।
It was nice to hear.
थैंक यू जी, अल्लाह हाफिज।
अल्लाह हाफिज जी, अल्लाह हाफिज। हमें आपको भी सुनना था लेकिन टाइम अब आप हो गया,
ठीक हो गया।
10 बज के,
नमाज का भी टाइम है।
नमाज का भी टाइम है। So we'll meet again and
इंशाल्लाह। ओके, अस्सलाम वालेकुम।